Hello friends, today we'll learn a very important concept in organic chemistry, that is the concept of curved arrows. So you see curved arrows in so many different kinds of reaction mechanisms, also in the resonating structures and while writing the hyperconjugative structures as well. So that is why it is very important to understand that how we use these curved arrows and what is the concept where we use them and what is the correct way of using these curved arrows. So I have written a few points, so we'll discuss them one by one. So the first point says that curved arrows are used to show the movement of electrons and not atoms during the chemical reaction. That means only the electrons movement is being depicted by curved arrows and not the atoms. Then the second point says electrons always move from an electron donor. Electron donor means the electron rich species. That means only electron rich species can donate electrons. That is why electron donor is the electron rich species. To an electron acceptor. That means the electron deficient species. The one which is deficient or lesser in electrons, that species can only accept the electrons. So that is the electron acceptor. So the arrows, they move from electron donor to electron acceptor. So we'll just look into an example regarding this. So this is OH negative plus HCl. So there's a reaction happening, so like this. So this is the movement like this, and we get HOH plus Cl minus. So you can see that here the OH group, the hydroxyl group, contains negatively charged, the whole of the group is negatively charged because of the oxygen. So this negatively charged group, this negative charge moves on to the hydrogen of the HCl, and then this HCl bond breaks and chlorine gets detached. So by the end of the reaction we have HOH and Cl minus. So as you can see, we have shown with the curved arrow that OH negative donates its electron to the hydrogen. That means OH is the electron rich species and hydrogen is the electron deficient or the electron acceptor, and OH negative is electron donor. So like this we have to shift the arrows, and this is the correct method of showing the movement of electrons and the formation of the bonds. Now if we show like this and then we write the product, if we show the arrow is getting shifted like this, because obviously there is a bond between OH and H, so we can show, we may think that we can show in the either way also. No, this way from hydrogen to OH negative is the wrong method. So this way it should not be shown. So this is the wrong way because hydrogen is electron deficient, so electrons cannot shift from hydrogen to the OH negatives, and electrons have to shift from the electron rich OH negative to the electron deficient hydrogen. So this is the correct way that has been marked with red. The green one is the wrong method. So we have to take care that while writing a reaction, we have to take care that which way our arrow is moving. Then moving on to the third point, what it says, the curved arrow always starts at the pairs of electrons used to form a new bond. So like if we write something like this, so we have this oxygen contains the two lone pairs plus, let's say we have a species A plus which is positively charged, and then we have C double bond O and A. There is a bond formed between oxygen and A, and we are left with only one single pair of electron, and like this. So how we will show that the bond formation with the shift of the electrons? So we'll start, since there is a bond between oxygen and the positively charged A species, so we'll show that one of the electrons from oxygen is moving towards the A species, and then it is forming the bond. So we have to take care that we show the start of the arrow from the position where we have the electrons. If we show like this, that we have something here, the same structure I am writing, so and then we have the same species. But if we show that the arrow is starting from somewhere here in the middle and then ending towards A plus, then this will be considered as wrong. Why wrong? Because we are making the arrow start from a position which has no electrons, that means in the middle position. So we have to be very careful while we make the arrows. So arrows should be such where it should start from the electron. So this is the correct method. So this is the correct where we have drawn with the blue, and this one, so this is correct. And the wrong one is you cannot draw an arrow just anywhere. You cannot start the arrow from any point. So it should be started from where we have the electrons. So this is what is being said in the third point. And then the last point is single-headed arrows are used to show the movement of single electrons. So you must have seen several reactions being written like this, that so this is in the product what we are getting. We are getting the free radicals. So you must have seen that in some reactions it is being shown that the arrows only have single heads, not double heads. So this is the single headed arrow. So it shows that there is a kind of bond breaking which is known as the homolytic bond fission. So homolytic bond fission, which shows that there is equal, the electrons, the bond, when it breaks, the electrons are distributed equally. That means one electron goes towards this part, one electron goes towards this part. So that is why we have this one electron with the CH3 CH2 species and one electron with the CH3 species. That's why we get the free radicals. So whenever you see a single headed arrow, that means it shows the electrons that are moving are the single electrons, not in pairs. So single electrons. So most of them, this kind of bond breaking is shown during the homolytic bond fission, which gives rise to free radicals. So hope you got a clear picture about the concept of the curved arrows, and hope this helps. Thank you.